at least some of these power supplies, they're GW or Instek GPC series. I have the 3020 here. The fans run full speed right off the unregulated 24 volt rail, and the noise was super annoying, and I rarely use it at high power levels. So I looked into adding a fan regulator. This is the first circuit that I tried. Well, it just simulated it. I copied this from some random PC power supply, and there's a thermistor here, an NTC, RTH. The fan is up here between the positive rail and this node here. And there's one power transistor, or it can be smaller if you're running off lower supply voltages, but on 24 volts at 100 milliamps, this actually heats up a fair amount. And this Zener diode, what this does is it ensures the fan always runs at a certain minimum voltage, which means even when cold it'll still run, and the voltage is determined by the supply voltage minus the Zener voltage. So let's say you put a 7 volt device here and you're running on 24, all the fan's always going to have at least 17 volts on it. Some problems with this. Well, first of all, this arrangement here, the thermistor, this voltage here is heavily influenced by the supply voltage. So if this is a regulated supply, there's no big problem. But in the GPC power supply, it's fed from an unregulated rail, and with no load, I measured it at around 27.5. And when I'm loading the outputs, it can get to 25 point something. I forget the exact number. Well, I simulated this. This is multiple sweeps, and the green trace is the voltage applied on the fan. The horizontal axis is temperatures. And this first trace here, that's 23 volts supply. This is 24 volts, and this is 25 volts. As you can see it's a super widespread, and I didn't really like that. This simulation is pretty nifty. It's something I copied from the internet. You can punch in the parameters for your thermistor, and you step a parameter. You can name it whatever you want, but you step that parameter and plug it into this formula, so you don't have to do a lookup table manually. So that's works out pretty nice. This second circuit here is also interesting. It's from this website here. By default, the fan doesn't run, which I thought I wanted initially, but I decided against it. It works quite differently. There's no Zener diode here. There's a pot here, or a trimmer, that controls sort of gain. You'll see the simulation, so it should make that a bit clearer. So the only thing I'm sweeping here, well, same thing as before, temperature down here, and those 3 traces, that's 10% of the potentiometer, the 30%. So the breakaway point here, well, it's set at 28, that doesn't really matter. And it doesn't change, but the steepness of the curve is adjusted by the pot. But it also, let me just change the sweep here. I'm going to sweep the supply voltage instead. Let's try that. So that's with a fixed pot value of 0.3. And as the supply voltage changes, first trace is 11 volts, that's 12 and 13. And same thing, it seems less severe than the other one, but it still changes a fair amount. This third circuit is a different approach entirely. Here's where I found it. It uses two comparators actually. The first one let me just simulate this. Well, anyway, see the idea. I'm generating it's a relaxation oscillator, so that's what's going on with this unit here. This one here is just comparing the thermistor voltage here and when it crosses this triangle wave, it switches on and off. It's a PWM driver, basically. So you tweak the frequency here and adjust your trigger points with this, and you're done. That was interesting, but the PCB was going to be a bit more complicated, and I didn't feel like getting into that. And number 4 is this one here. I came up with that on my own, but I'm sure it's been done before. There's nothing groundbreaking here. Here's my thermistor up there, and here is a threshold, and there's a bit of negative feedback here with R6, because if I don't have that, it's just going to work as a comparator, so it's going to be full on or full off. That's no good. And on the output here, this is the fan R4, and there's a diode here. That's the first thing I tried. Was a Zener diode that's 7.5 volt, and if I wire this up like that and remove R7, what this does is, with cold temperatures, the op-amp is going to be driving this output as low as it can, so maybe 2 volts for crappy op-amps. And with 2 volts here plus 7.5, that's about 9 here, so it ensures a minimum voltage on the fan, just in a different way. I didn't have a high enough power diode for that, unfortunately, because of this resistor. I'll explain this a bit differently. When sizing this resistor, this is a compromise. If it's too high, there's not going to be enough base current to saturate the transistor, and if it's too low, then you get plenty of drive here, but this poor op-amp has a really hard time turning off the transistor, like absorbing all that current. So this is the values that I came up with. It's reasonable. The op-amp, it's a 741. Very basic op-amp, pretty weak. But with these values, it works fine. The op-amp dissipates, I don't know, 100 or 200 milliwatts. It's not a huge deal. And I also have a simulation. And this sweep, I got a bunch of stuff here. This is, what is that? That's power wasted. Well, it doesn't matter. The important ones are the red trace. That's the fan voltage. As you can see, the minimum voltage is roughly 6.5. Starts ramping up at 19 volts, and at 28 Celsius, it's full voltage. Alright, I'm just sweeping the supply voltage this time. And that's from 23 volts to 26 volts. There is a difference, but it's pretty minor. I mean, less than a degree. And that's what I was looking for, a fairly stable characteristic. The values here are 6, and the value of this divider, it looks messy, but it's just 2 fixed resistors, and that's supposed to be a pot. I didn't do anything nice. It was just for a quick test. So these combine to define both the starting point and the slope. So I played with these values a bit till I was happy with the result. This is the final circuit that I built. It's a lot like the simulations. The only difference is this part here. I have 3 thermistors mounted on each of the pass transistors on the heat sinks, and they're just combined with diodes here with a resistor, because the 741 has a fair amount of bias current, so I couldn't go much higher than that, but it doesn't matter. I'm not measuring anything. It's just version 2 or 3. I'm not too sure. And I was just testing it, and it should work now. Got the fan going. If I warm this one up. Yeah, that'll be better. The pass transistor here is always... there we go.